So in Algebra 1, there was a topic you would have gone over just briefly called direct variation. And that's this first little topic right here. So if you want to grab a pen or pencil or something and kind of do one of these numbers, this little section is going to talk about what's called direct variation, which is not what the lesson is about, but is a good reminder of something we've learned before. Direct variation occurs when two variables, x and y, are related as follows. So this is important right here. That y is equal to ax. Now, what's interesting about this is that we have a constant of variation that is going to, and the key words here, you're going to see the words vary directly, which if you remember in Algebra 1, we said to cross that out and write the words divided by. So if you had a word problem that said x varies or y varies directly with x, you would take the y variable and divide it by x because it varies directly. And the reason why that is because if you take this formula right here and we solve it for a, which is weird, we want to get a by itself. What would I have to divide both sides by to make the a be the only thing on its side? What do I want to cancel out there? If I only want a on that side. Yeah, weird. We're going to divide by x. Feels like weird. We've never done that before. That's okay. When the x's cancel each other out, we would have a is equal to y divided by x. And that's huge for us. This is our indicator that our constant of variation is actually direct variation, because the constant is a quotient. So a is a division problem or a quotient. We'll write the word quotient, and because I know we never remember what quotient means, that is division. If you solve for a and you get a division problem, then it is called direct variation, which again is not what this lesson is actually about. This lesson is actually about something called inverse variation. So it's kind of like the opposite of that, basically. If we look at inverse variation, the way that they're related is different. Compare what I've highlighted in red to what I've highlighted in blue. What do you notice? What's the same in all of them, in the red and in the blue? Yeah, the restriction is the same. It's always going to be a not equal to 0. Okay, cool. What else is the same? What do they both start with? Y equals. But what's different about them? One's a fraction. Great. When you see the one that has a fraction in it, that's called inverse variation. And we would say that they vary indirectly. We put the prefix in on the word directly to mean not, so not directly. And what's interesting and weird about this is if we took this equation just like we did for the red one, and we solved the equation for a, meaning I want to get a by itself, what would I need to do on both sides to make that happen? Multiply by x. Okay, weird. We've never really done that before, but we can. And when those x's cancel each other out, oops, that was not what I wanted to do. What we're left with is the equation a equal to x times y. So this time, oddly enough, the a value, when we find the constant of proportion, it's a product. Which, if you never remember what product means, that means we multiply them together. And that's what we're going to need to be doing first in our lesson, is truly deciding if a relationship we see is varies directly or varies indirectly. So we're going to be looking for our constants or our plain numbers to either be equal to a fraction of y divided by x for direct variation, or a product for it to be indirect variation. Okay, so let's see a couple examples of what that means in like an actual problem. So we're just going to decide whether these A, B's, and C's, problem A, B, and C, are direct variation, inverse variation, or neither, because it could not be any of them. Now in this first one, we want the constant by itself, because that's what we're looking at. That's what we put in the little bubbles. The constant to be by itself is the number, straight up number, by itself. Yes. So we look at what is left. Is that a fraction or a multiplication problem? Since it is a product or a multiplication problem, we know that this is inverse variation. For the second one, we actually have to do some work to make that happen. We want to get, again, the number by itself, which is weird. We've never done that before. We always be trying to get y by itself. That's not what we're doing this time. We're trying to get the 2 by itself. Well, first things first, it's in the denominator, and I don't like it being there, so I'm going to multiply both sides by 2 so that I can get that 2 out of the denominator. I would have the equation that says y equal to 2x. Now again, we're trying to get the 2 by itself, which is a weird concept. We've never done that before. What do I have to divide both sides by to get the 2 by itself? X. Weird. Okay, we do that. The x's are going to cancel each other out, and I would have 2 equal to y divided by x. Once I have the number isolated, we decide if we have a quotient or a product, a fraction or a multiplication problem. Well, which one is this one? Is it a fraction or a multiplication problem? Fraction. And since it's a fraction, that's a quotient or a division problem, we have direct variation. So the difference in these two problems that you're seeing on the screen right now is that in the first one, when the number was isolated, the x and y were right next to each other, multiplied together. When that happens, it's called inverse. When we solved the other equation where it says 2 equals, so the number just straight up by itself, we had a fraction. So we call that direct variation. So product means inverse, quotient means direct. But that's not the only option for these kinds of questions. In part C, again, we want to get the minus 4 by itself. So we need to move x to the other side. It is not currently multiplied by 4, so we have to either add or subtract it to go to the other side. Are we going to add or are we going to subtract? We're going to add the x. Yeah, if we want to bring it over here. It's already positive, so how do we undo positivity? Subtract. So we subtract on both sides. It's going to cancel out the x's on this side. And we would have y minus x equal to negative 4. Fabulous. This is what we want because the constant or the straight up number is already by itself. So we look at the expression that we have on the other side. Is it multiplication? No, so it cannot be inverse variation. Is it a fraction? No. So it cannot be direct variation. So if I eliminated both answer choices, you would just answer with neither. Because it is not a product and it is not a quotient. That's a whole subtraction problem. If you end up with subtraction or addition, you say neither. So now the next thing that's up is for us to start classifying not just equations, but classifying data sets. So we're going to do the exact same thing where we need to figure out the constant of each of these data sets. To remind ourselves from the stuff from the front page, we know that if we have the constant being a division problem, then that is direct variation. If we have the constant being a multiplication problem, then that is inverse variation. So what we have to do each time is we have to check to see if it's direct or indirect, direct or inverse. Meaning, for each of the data sets that we are given, we are going to try the direct and the inverse pattern to see if it's the same. So if I were trying the direct pattern, meaning I want to take all of the y's and I want to divide them by x's, what I would do is I would say, okay, the first column or the first set of points has a y value of negative 12 and an x value of 2. What is negative 12 divided by 2? Negative 6. So really, this value is negative 6. If it is negative 6 across the whole thing every time I divide y by x, then it is direct variation. So if I do negative 6 divided by 4, what is negative 6 divided by 4? Yeah, that might be a calculator question for you. It's definitely not a whole number. And as a fraction, because we know I prefer fractions. Negative 3 over 2, correct? Fabulous. If we do the next column, we are going to be doing negative 4 divided by 6, which we'll fast forward. I know we can type stuff in a calculator, is negative 2 divided by 3. And the last one, when you do y divided by x, you'd get negative 3 divided by 8. Are all of those numbers that I wrote down in red the same number? Yeah, they're not the same number at all. So it is not direct. It is not direct variation. After we try the division, we're going to try the inverse pattern, which means we're going to multiply x times y. If we get the same number across the entire line, then it is inverse variation. So this time we're just multiplying them. We're going to do negative 12 times 2. What is negative 12 times 2? Negative 24. Okay, great. So that's what I get for the first one, negative 24. Then I do the second one. What is negative 6 times 4? Negative 24 again. Oh, that seems promising. If I keep going, what is negative 4 times 6? Same thing. And what is negative 3 times 8? The same thing. When that number is the same across the whole column, across the whole table, then you know that is correct. So this is an inverse variation. If you were to do both the direct and the inverse and neither of them were the same number across the entire thing, you would say neither. Does that make sense? Because y'all are going to do examples, the next two tables. So ask me questions right now because you're going to try the next two. What did I do in red up here for all of the different data points? We divided, specifically the y divided by the x. Okay, we do that all the way across. If it's the same number, you write direct, you box it, you're done. If it doesn't work, you try this, where we multiply them all the way across. If it's the same number, you write inverse, you box it. If that's not the same, what should you write? I just gave you the answer. If neither of them are the same across the whole thing, what do you say? Neither. Okay, great. You've got the next two examples I want you to try on your own. So tables number 2 and 3. Here we go. So if you got stuck on this one, we'll do one more together before I'll give you more time for the second one. We want to try first to check inverse variation. So I'm going to do this fraction, y divided by x. If I do that for the first one, I would have, and I'll show my work on this one in case you're like, I don't know where these numbers came from. 2 divided by 1, which is 2. Check. I would have 4 divided by 2, which is 2. Okay, that's promising. But when I do 8 divided by 3, do I get 2? No, I actually get 2.6 some. I'm going to leave it as the fraction 8 divided by 3. And if I do 16 divided by 4, I would get 4. So are these numbers the same all the way across? No, so it is definitely not direct. Bummer. That would have been nice if we had been able to stop right there. So we try inverse. To try inverse, that means we are multiplying them. Cool. We multiply them. That means I'm doing 2 times 1, which is 2. And 4 times 2, which is 8. Oh, yikes. 8 times 3, which is 24. And 16 times 4, which is 64. Are all of these numbers that I get after I do that multiplication, the product, are those the same? No, so it is not even inverse. So how do you answer this one? Neither. Is that what you guys got when you tried this one? Uh-oh. Thank you for your honesty. Let's try one more. You've got the third table there. I want you to try that one more time. Now that I showed my work, maybe it's a little bit more clear on what I'm doing here. For this second one, when we go to do this, I like starting with direct variation, which is the red stuff, so I'm going to divide each of them. I would do 20 divided by -4, and I would get -5. Cool. Then I would do 15 divided by -3. I'd also get -5. Promising. 10 divided by -2, ooh yay, -5. And 5 divided by -1 is still -5. So if they're the same all the way across, how would you answer this question? Direct. This is direct variation. Now just to prove it to ourselves, because it is our notes, if we show the blue part, show the inverse check, 20 times -4 is -100, no, not -100, -80, my bad. 5 times -3 is -45. 10 times -2 is -20, and 5 times -1 is -5. Obviously, those are not the same, so we've convinced ourselves it's not inverse. Now, of course, once you find the answer, you don't really need to do all the parts, but it's a good check because it doesn't take us very long to just check both, just to make sure we didn't make a mistake somewhere. Easy peasy. Make sense? So far in the notes, we have looked at equations to decide if they were dividing, which is direct, or multiplying, which is inverse. And then we looked at tables to do the same thing. We just had to find the values for each of those data sets. And then we're going to start writing our own inverse variation equations. This is what the problems might look like. It says, the variables x and y vary inversely. That's important. Let's circle, highlight, star that word, vary inversely. And y equal to 4 when x equal to 3. Write an equation that relates y, x and y. Then find y when x is equal to -2. Now to tie this back to the way that we did these problems in Algebra 1, when you see the words vary inversely, I want you to mark them out and write the word multiply. Because vary inversely is going to multiply my x's and my y's together. When we did this in Algebra 1, we saw the words varies directly, we marked it out, and we wrote divided by. So we mark it out, we put multiply, it's the opposite. That means that my a value is going to be the multiplied version, x times y. So this is the first step, and we're going to label these steps so that you can look back at your notes and follow the steps. So if I find a, that means I need to take the x and the y variable or value that they gave me in the problem and multiply them together. So what is 3 times 4? 12. So my constant of invariation is 12. That's great, we needed that. This isn't the final answer, so I'm not going to put a big box around it, but I'm going to put this like dash box to alert myself that that's important. Once I find a, I look back at the front of my notes for the type of equation that we would write. The equation that we write for inverse variation is y equal to a over x. This is from the very front of the page. We highlighted it in blue. Say again? Yes, sorry, this is step 2. Thank you. But now that we know the value of a, we found that in step 1, what should I put up there at the top of the formula? 12. So instead of a, I'm going to put 12. Check. Again, this is not my final answer, but it is the answer to this step. That's the equation that it asks me for. But the third part of this goes on to say, find y when x is equal to -2. So we're going to take this value, -2, and we're going to plug it into our new equation. We're going to plug that number -2 in here, in the formula. Okay, so I'd have 12 over -2, and what is 12 divided by -2? -6. That's my answer. So the 3 steps here are, number 1, find your constant of, or your a value. Sorry, lost my train of thought. Find your a value by multiplying them. Plug that a value into the equation. Plug what you want to know into the equation to get what you got out. Does that make sense? Can we do another problem, but y'all are going to lead me through what to write. It's the same sort of problem with different numbers. It says, the variables x and y vary inversely. Okay, I marked that out, and what do I write instead? Multiply. So I'm going to multiply x and y. We know that y is equal to 8 when x is equal to 4. Let's pause right there before we keep going, and let's do step 1. What should I write down for step 1? A equals to x times y. Amazing, because we know they should be multiplied. Okay, Yuli, what is x and what is y? 4 and 8, yeah. So when we multiply 4 times 8, beep, beep, bop, we can do that in a calculator, we get 32. Amazing. That's my a value, or my inverse constant. What do I do next? What's step 2? What formula am I trying to fill in? That's the formula for an actual inverse variation equation. Remember, this is from the front of your notes. But what is the only letter I really need to fill in right here? A. And didn't we just find A? Fabulous. So what should I write as my answer to this step? 32 divided by x. Amazing. Okay, there's my equation. So if you have a problem on your homework, which you will, that asks what is the equation, that's what you would type in. But this question keeps going and asks me to predict something about the future. It says, then find y when x is equal to -16. So what should I do with the number -16? Plug it into x, because we know exactly where x's belong in this equation. They belong right there. And if we have this x value, we can just plug it in. So we have 32 divided by -16, which we can calculate real fast. What is the value of y? Make it negative, but then yes, because we plugged in a negative. Awesome. Does that make sense to us? So that's a level 1 style question for me because it doesn't have any context. But the next question we're going to do is a real world contextual question, but it's the same stuff. Okay? This problem says, the time t in hours that it takes a group of volunteers to build a playground varies inversely. Oh, we see varies inversely. What do I mark that out and write above it? Multiply. So I'm going to be multiplying the hours with the number of volunteers. Okay. It takes a group of 10 volunteers 8 hours to build a playground. Part A says, write an equation showing how time changes as the number of volunteers changes. Solve for A. Okay. Well, here's what I know. I know that the A value will be multiplied when I multiply two things together. In the first problem, we used X's and Y's. In this problem, what letters are we using? T and N. T stands for time. N stands for number of volunteers. Okay. How many volunteers did I have? 10. How many hours did it take them? 8. So what is my A value here? 80. Did we follow? We just still plugged in the numbers that we got into the multiplying question to get my constant, my A value. So what we're going to do now is we're going to write the equation. Now, normally the equation was y equal to a divided by x. But are we using x's and y's here? No. We're using t's and n's. T's and n's. Okay, great. Well, if this is t's and n's, still the only really thing I need to plug in here is the a value, which we just found. What's the a value? 80. So I would have 80 divided by n. Let me go ahead and make this right. I'm going to make this green so you know this is where this came from. And there we go. This particular question just says write an equation. Boom. There's my equation that shows how time, that's why time is by itself, time changes as the number of volunteers changes. So it's literally the same as the problem we did before. We just changed the letters. No big deal. But then we're going to use this idea. It says, okay, cool. Now that we know how it changes, we have an equation. Make a table showing the time that it would take to build the playground when the number of volunteers changes and is 15, 20, 25, and 30. Okay? What we were wanting to do here is find out what this value t would be when we change the n value to different things. For the first change of the n value, what number should I use? 15. Okay, cool. So I'm going to change the n value to 15. What is 80 divided by 15? You can give it to me as a decimal. That's fine. 5.3 repeated, right? So it'll take 15 volunteers 5.3-ish hours to build this playground. If we increase the number of volunteers by 5, should it be getting quicker to make the playground or longer to make the playground? If we add more people working on it. Quicker. Let's figure out how quicker. If we do 80 divided by 20, what do you get? 4. So it should only take 4 hours for 20 people to build this playground. Have you ever tried to build one of those playgrounds? Ever? I think I built one for my nephew. It took me like 3 days. So this would have been nice for it to only take 4 hours. Many trips to Home Depot later, we got the playground built. Okay. No, it was like from a box. I'm really good at putting together IKEA furniture, but this one just got me. It was the swing. Couldn't figure out the swing to save my life. Okay, if we increase the number of volunteers to 25, what's 80 divided by 25? 3.2, so it would take 25 people 3.2 hours to build this playground. And if we increase it even more to 30 volunteers, how many hours would it take them to finish this? 2.6 repeated hours. So the reason that we study inverse variation is kind of like this conclusion question right here. It says, what happens to the time it takes to build the playground as the number of volunteers increases? So as we increase, so as these volunteers increase, what's happening to the time? It gets quicker. This is where that old adage, I don't know if y'all's, my grandpa always said this. Many hands make light work. Have y'all ever heard that saying? Okay, so many hands make light work. The more people we have that are helping, doesn't it go faster? So as the volunteers increase, the time does what? It decreases. Yeah, it gets faster. That's why it's inverse variation, because one of them is going up, we're increasing the number of volunteers, and the time is going down. Direct variation was the opposite. In direct variation, it would be like the number of volunteers increased and the time it took increased, which doesn't work for this scenario because it should be going down. When they're opposite directions, one goes up, one goes down, that's inverse variation. Last year when you learned about direct variation, they were both going the same way. As one goes up, the other goes up. As one goes down, the other goes down. But inverse is the opposite, like these arrows are going the opposite.